What's up? Papa Bale, welcome to the channel. Doing a live stream here. I'm demonstrating a few things. A lot of haters out there about the 9-magnet rotor. I mean, Jesus. All right. Okay, so I'm going to get right to it. It's a flywheel, a 9-magnet flywheel. So let's turn this on. Today we're gonna work with kind of like an SG circuit or two SG circuits, and we're gonna power this motor with this SG over here. That's pretty powerful. I mean, look at that thing go already. It's like, wow. That's 9 magnets. So here, let's turn on the second gear and see what happens. Whew, that is freaking awesome. Now watch when I turn it off. That was pulling 2 amps though at 24 volts. That's crazy. That's like, what is that, 50 watts? All right, while we're sorting that out, I'm gonna look over here. Currently, I have a 12-volt battery on this side. Yeah, the power is off on that motor. I think that inertia is dope, man. It's just awesome. So this is a 12-volt battery pack for this motor. But what I want to do is I want to hook up an SG extension to run this. Isn't it a lot brighter out here? I mean, isn't the light like a lot more? You can see everything better. Hey, hey, welcome to the channel. Hola. Hello, hello. I'm testing out my 9-magnet rotor here, seeing its flywheel capabilities and other things. It's all brushless motor. This one's misbehaving. I think it's because of the transistor. Because it's got a Litz wire coil. It's really powerful. That is not an example of how well that thing runs. So I think I'm going to have to get a new transistor. I mean, it's kind of working, but it's not. All right, so this one has two 24-volt circuits. We got, I don't know if you can see this. I'm going to have to adjust the camera. There's two 24-volt batteries over there. And they're hooked up in series for 24. And then I got a power supply for the other circuit, 24 parallel. So that's 24 volts parallel, which is super dope. And if we look at it, you know, if we turn them both on right now, to 24, which is crazy. Look at that thing go. That is super awesome. And that thing will spin for 20 minutes like that. Now the trigger coil I've got for one of these is so small that it's awesome. I can put it in the hole of this coil. It's right in the hole. It's cool, man. It is so neat. And then the other one is this one. I'm going to make another small one. So the power is off now for this one. Now I have a here it is. This is going really slow. 716.3. Let's see if I move this trigger coil around a little bit. It's not the right way. Yeah, that's awesome, man. It's still going really fast, and it's off. Making sure that it is off. It is off. Yeah, I don't like this one. Used to go like 2,200 RPMs. I don't know what's going on with it. It's probably a connection somewhere is like whack backing. But I don't know. We'll figure it out though. So I've been, you know, working, trying different amounts of magnets on the rotor. This one has 9, and it's awesome. It's 100% infill on the 3D printing, so it's really, really heavy. It's literally like a kilogram of plastic. But I can do 2, 3, 4, 6, and 12 in this one, and this one does 9, 3, 9, and 3. So we can do an example for 2 real quick with the bigger magnet, the bigger magnets. I love this rotor, man. It's so heavy. It's awesome. So, wow. In comparison, man, it is like so awesome. And you'll see the difference. This one's really, really light. The heaviest thing on it is the magnets, though. All right, let's turn this. So that's two of with magnets of greater, much greater power. Lots of wind off of this one. Wow, I can feel this is a strong breeze coming off of that thing. Awesome. Well, hello everybody. Welcome to the channel. All right, so that's a 2-magnet rotor right there, running off of this one and this one are both drive coils, and everything else on there is basically designed to trigger or to pick up. Hello, hello. How we doing, everybody? All right, so we got the 2-magnet rotor right here. I've been trying all the different types, up to 9 so far. This one is running on a Litz wire, and something's not right with this. That should be going a lot faster. I don't know what's going on. I'm pretty sure it's a transistor. I mean, it's working, but it's not working like it should. So I don't know exactly what the problem is. The axial flux one right here. It's running on a 12-volt battery pack, lithium ion. I'm loving this though. This is awesome. I mean, if you think about it real quick, you got to adjust the trigger coils for this one because they don't line up like an odd number. Okay, so this one, and this is its trigger, so it's got to move slightly to the side, like, and then this one goes here. So when we line up a magnet with that one, oh, we caught it. All right, we line up with the 120 degrees. We got room to do that. You don't have to line up at 120. It looks pretty, but you don't have to. You can line it up with the magnet right next door, and it'll work just fine. And currently the cores are not in. I do have cores for each of the drive. I was working on a battery swap, like a 12-volt battery swap thing, but the coils that I had were not generating enough to compensate for the cost. Run it. Huh. Must unplug something. Let's check. I want to get this funky thing out of here. Sixteen gauge drive coil. Very cool, man. This thing is powerful too. Let's see. Now I gotta check this because I feel like hmm. Yeah, I'm not getting an amp draw on power over here. So I'm thinking, and that transistor was a little warm. Like, oh, here it is. This is it right here. Okay. There was something. All right. That makes me feel better. All right, let's try this again. Huh. At least the one drive is working. Catch up. Heck yeah. All right. So What do we do? Oh, what do we do with the front? All right, let's give it one more shot here. Huh. I want to get this untangled. I don't want my ends to break. There we go. There it is. Yay. That's only a 500 milliamp draw on 24 volts. I think it's because of this coil. I got to do something. There we go. Yeah, it's really sensitive. All this stuff is kind of sensitive. Sweet. So we took this coil and we put it in this bobbin. Kind of awesome. All right, so oh yeah, the power is off. That is so awesome. I knew it would be something like that, but I didn't understand that it would be like that. That's cool though. Hey, hey. All right. Have a wonderful day, everybody. This is awesome. Those people that have to go. But if you don't have to go, stick around. And we're going to make this flywheel power this motor. I got to get from one collector to another, basically. We got our diode here. Should I spring for a resistor in there too, you think? I don't know. I don't know. 'Cause I use 20 gauge wire in the breadboards. It's nice and stiff. All right. I'm wondering if I should change it to a 12-volt system. I think I'm going to do that. I just want to see the power. You know, who doesn't? .5 amps on the one that's running this. Oh, it looks like it's 0.6. It's continually going up though, because it is now running both. The 0.6 is where it's at right now. It's going to 0.7. Something's wrong with the coil, I think. Try spinning it the other way. Just make sure I got that. It looks like it's working. Maybe let's try the Tachometer on it. No. Might not be in enough. Let's see. Been having troubles with that one all day. Let's try moving it over here. All right. Let's get the tack on this because it spins pretty good. Huh. Wow, I swear I had it working just a little while ago. Huh. Yeah, the transistor is hot. I need to poke through the film. Turn it back on. Now, if this one starts working, it should make this one work better. All right, what else could be going on this side, I wonder? I'm gonna try swapping the strands on the trigger coil. And despite all the new light we have, still pretty hard to see. Nah, this one doesn't look like it's working. All right, I'm gonna try like one more thing, and then I'm gonna swap the transistor. We're gonna check our connects. All right. That would be awesome if that's what the problem was. That means an easy fix. Do not try this at home. All right, man. I'm cutting the power. I'm not going to shock myself right now. All kind of intermingled. I'm going to plug this into the ground. I had it plugged into the emitter because that's kind of the same thing, but that shoves it back into the coil. This is going to go straight to the ground now. Oh, that makes perfect sense. So we might put that back, but we're going to plug this in. All right. Since this transistor is going to power that motor, I need to ground this to the power supply that this transistor is grounded to. That one. There. Now, let's do it. That seriously, I hope it works right now, because that would be a lesson learned. Can I just ground it to this, do you think? Because it doesn't seem to be working. What is this for? Oh, ground, ground. I'm going to try that. That's definitely not working. Holy shit. Yeah, that's not good. Oh, okay. So, got a little hot. So I'm going to go down to 12 volts. There is, honestly, there's no need for stuff like that to happen. And you know why that happened? No, it's not. It's because it's because everything was touching. I don't know if it'll still work. I think it might even still work. But I don't think that was a transistor. It was the enamel on this wire. I mean, the transistor was what made the heat, but I don't think I think it was an intolerable measurements. All right, should we test that theory? That's what I thought. Granted, they are getting quite hot. So I'm going to let it chill for a second. Might have the wrong type of diode. Oh, that really did not feel like it was in there enough. That's not good. All right. Anyway, I'm going to hook up this 12 volt power. This is going straight into the collector. I don't know if that's good or not. I don't think it matters really. Now I think these are wrong because I switched them. Remember I switched them? I don't think it works this way. I think it works this way. And it does matter. It matters a lot. We'll see if I'm right. I don't know at this point. That felt good. Hell yeah, here we go. That's where the money's at. 12 volts. That'll get going pretty freaking quick. All right, let's get a big number on the tack right here. So it's 11,455 divided by 9. Let me get a tack strip on there, actually. That would be more, give us a better idea. This is awesome. So all the haters about the 9 magnets, I only got one thing to say, and I'm not going to say it. That is awesome. That is off. That is, wow, this feels really, really, really fast. Let's check it. 1,774. Almost 2,000. 12 volts, man. That's freaking dope. Because it's not done yet. $1,782. We need a piece of tin foil, which we have right here. I just don't feel like doing the math. Like, 20,000 divided by 9 or whatever. Go grab some super glue. Be right back. Let's get a quick test, and I'm going to let it chill for a second. Yeah, 1783. All right, I need a little bit more of a dab. All right, let's get a good tack reading on this beast. I'm thinking it's probably going to be going, I'm hoping around 1,000. And at 1,000, 9 magnets is generating a lot of electricity if I set it up that way. Yep. 976, 1,025, 2,100, 1,200, 1,213. So it's over 1,000. That's awesome. 1,328. Yes. 600 milliamps. Probably on both circuits. 1,400. See, the tricky part is with all these different power supplies is to where to ground your stuff if you're using like an SG extension. I've totally forgotten like where to put the ground for the coil and the ground. Well, just, yeah, the ground for the coils when it's not, it doesn't have its own power supply. And maybe we can get this thing running with the SSG. Yo, 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 what's going on? All right, let's see. Let's try this. I'm going to put my mic down. There, I hope you guys can still hear me. At least better. Not, I apologize. All right, let's give it a shot. I got an idea. This one. All the way up here. Might have to get a longer connection. Put it right in the ground. Power supply. Let's choose her. Pretty nice. It's pre-made. It's P.H.Jr. Bought it. Bought two of them. Well, wherever I put it, it's going to increase the amp draw. Where, I don't know exactly where I should put it. Using that one. So, I guess I'll put it here. All right, let's see what happens. We got it. Looks like we got it. It's a 24 volt SG. Awesome. That is so right. That amp drying, no joke though. They're like 3.5 amps at 25 volts. Nice. So should I downscale? Check it out. Working. And the SG connection is working. It's drawing as an extension from this transistor to power this. This is no longer hooked up to any sort of power supply. It's like that. So how we do this, I'm going to turn this down to 12. Disconnect series batteries. Voila. Here we go. Let's run it on 12. Just for it's working. Oh yeah. Oh, we're working. Still a lot of amps. 0.7 amps. Oh, it's running both circuits. Just 12 volts. Almost looks the same. That ice water is good. I like it. It's not like it's good as in it tastes good, because good things don't have to taste at all. Okay? So alright, let's see here. With 12 volts through extension, we're going 1400 with this one. 1080 this one. I got an idea. Here, we're gonna move the power supply. Here, let me see how much juice is left in this battery. $11.7, $11.80, 81. So a little under 12 volts. How about this one over here? $11.73. So we can use one to charge the other currently. Can't charge them both at the same time because it's not a 1-to-1 ratio and you're spending more than you're putting in. Just because of probably coil design, honestly. Those coils do not generate enough, or I'm hooking it up wrong, one or the other, for a generator. But this way, and let me get my coil. There it is. Yay. And that might look familiar to some people. 18,000 turns of 32 gauge. We'll put it like right there. Okay, so what we need is 2 diodes and 2 clips. There's 1 clip. There's 2. All right. All right. Actually, we're going to need 2 more clips. Because we really want those diodes. All right, let me get my one more clip. Here we go. Actually a nice diode in here already. Like that one time you got that iPhone for me with all those names on it already. That's clever. All right, let's see if we can gen this battery a little bit. I'm gonna plug the multimeter onto this. Just keep an eye on it. And we can double up on. That's cool. That'll work really good, I hope. With that much speed, gen real fast. All right, I will be right back. All right, here we go. Turn this on. We're going to see if we can't generate, charge up this battery real quick. Sound good? Sounds good to me. Let me turn this up. Hell yeah, we're charging it. It's probably going real slow, but we're doing it. Got some Velcro. Stuff is cool. It's not really worth doing, I don't think. Not like this. Turn that down to 12. Sweet. Let me look over here. Maybe I was wrong about that. What do we need here? Capacitors? Let's do a cap. Do this cap. Hmm. Let's see. I don't know. We are pulling 1.3 amps on 12 volts. This is definitely not charging. Well, it probably is, just really, really slow. Wow. Okay. Oh. Haha. That's not even really funny. There we go. It's a 2.7. Hmm. So I guess something that we could look into would be like a jewel thief. Oh, but there's a diode on it, so I don't know. There's two diodes on it, one on each end. I don't really know. I know that my motors are running, That much I know. There's some AC readings just to see if the coil is functional. I'm loving my new space though. It's really kind of eye-opening to be able to see. I know, really awesome. So 130 volts of AC. Now, if I did a bridge rectifier, would that work? I could go check it out. I'm gonna grab one. Be right back. That's 130 steady volts of AC. Oh my God. Totally forgot what I was coming in here to get. I hate that. It's like a total like memory wipe. Just happens too much, man. It's not fun. Huh. Oh yeah, bridge rectifier. Hmm. Wait. 190 AC. Well, you know I can see, and I'm definitely screwed up. It's all kind of messed up. All right, here we go. Now, from the bridge rectifier, do we want to go to the cap? I wonder. Now, there's like several things that I can use, and I gotta figure out which one it's going to be. Either a jewel thief or something else that generates a lot of power. Okay, this will go to the ground, right? And this will go, let's see where we're going to clip it. And I think we're going to put it and put it to the cap. Hmm. charge that one anyway. Then we'll do a diode from the cap. I don't even know, like this cap, I don't know if it's real, honestly. But I think the Velcro is going to signify quasi the end of the glue. Not necessarily, but that's the goal. It is charging. There it is, 1186. Way to go. All right, here we go. Here we go. Now 12 may be too small to get. There it goes. A little bit of a damn draw. Awesome. All right, so we'll give it some time. It's going to take a while, I'm pretty sure, because it's only using currently magnetic induction. When a magnet passes, it gives it a burst of energy. There's no power going through that, so it's going to take a long time. I wonder right now if we take the power from the far motor and let's just do this right. I think, yeah, that's right. Okay, it's all going in that one. So instead of running this motor right now, now I don't know necessarily what's going to happen when I just come on. There we go. I hate it when things like get stuck. All right. We're pulling 2 amps, 2.1 amps. We're not charging. I think I got a lot more out of this with the reed switch. But here, I got one more thing I want to really analyze. And that is the internal trigger coil. This one. All right, I think I put those on backwards. Now, I was using the external trigger because the internal ones weren't working. But we're going to try the one thing I didn't try. Maybe a few things. It's working. Yeah. Well, I don't know. It's working. It's just really not good. Let's see if putting a core in there will help. Oh, I know what we can do. It is charging. I don't think it's charging. So that's the internal trigger. You can see how much better the other one, the external, is. That's hot. Oh, man.
That's myself. Myself is not the one making this. Oh, yes.
So it works. It just doesn't work that great. So we're going to switch it back. Let's see if we get it right or we have to switch it. So yeah, what I do is I try and get it to a state that I want you to see it in, and then we move on. There's a lot to do, very little time to do it in. It's not because the world's going to end, it's because you're going to eventually die. It's just the way it is. So if you act like you have all the time in the world, that is a mistake on anybody's behalf, I would assume. You just don't have all that time. Even if you can travel through time, you will eventually die. And kind of like a self-fulfilling prophecy right there. Let's see if I can get it right this time. Hate it when they don't go in. Especially like the 32 gauge plus. It's like, come on, man. This is getting annoying. Got it. All right. So,
No well. There's no well. There's no well in Texas. I don't care.
oh, looks like we got an end. I don't know. Man. What did I do? I'm already like kind of overwhelmed here with all the connections. You know, I try to make it crisp. What to do? Hmm. Nope, we're not getting any amp draw on this one. I'm feeling like transistor. I don't get it though. I don't understand. It was just working, and then I picked this up and moved it around a little bit, and it stopped working. So I think I'm going to check these connections 100 times. I got an idea. It's not a fix, really. It's just kind of like a swap until I get whatever's wrong with that figured out. It's probably the transistor. I mean, more than likely. But we're going to hook the power supply up to the circuit that works. Is it really that bad? What the hell? So I hook up the internal trigger coil and everything goes to crap. That's discouraging. To anybody who's going to try and do stuff like this, it's just not okay. And I don't smell anything burning. I don't smell it. I don't smell any of the telltale signs of. There we go. Let's see. This works. There we go. Huh. Man. Need to get more sleep for sure. 1.3 amps, 24 volts. Yeah, that's good. 1.6. 24 volts, 1.6 amps. 1.7, 6. Twelve volts. So we can figure out how to charge the batteries efficiently. I think the flywheel is awesome. 9-magnet flywheel. Oh yeah. And that's the power we're getting from the connection. So I am going to connect it to its own battery, and you'll get much, much more out of it. And then the cool thing about tonight, when I shut down, I'm going to clean all this stuff up before I go to bed. That's the cool part. That's gold. All right. I'm going to turn the power up. Mm. Yeah, this is drag. It's like sucking the life out of me. And it sucks. Just to let you know, man. Like when it works, it invigorates you, and when it's like something happens and you don't know what it is. Well, I've only been doing this for like 2 years now, 2.5 years. So I'm not beating myself up over not knowing what's going on. I mean, that's not even a bachelor's degree in whatever the fuck this is. So I don't know. Hmm. I'm definitely like not a Rembrandt. I would think that if I knew anything about this, it would work more than it does. I like the 9 magnet rotor though. That motor over there is working. It's working great. Mm. Goes about 1,300 RPMs. So for 9 magnets, I say that's really good. That transistor is very hot though. I don't think it's blown, but I think it's not working right. Let's see if this littler one will work. Hmm. Got to take inventory to see what I have and what I don't have. Right now, it looks like I need transistors. So it's working. Just gonna line it up. And I wonder if I should throw it the other way. Can't really whip it that good that way, but we'll see what happens. I love that hum, man. That's it. Yeah, I love that. All right, so I'm wondering what will happen running this one with more voltage in it. And we'll, I don't know. This is how we roll, so don't know if it's going to be much more like quality of life improvements. All right, let's see. Here we go. 24 volts on the outer rim there. Do 12 volts steady power. See where it gets us. .1 amp draw. Wow, 0.8 now. Going fast. It's got quite a bit of an acceleration phase, but the Litz wire really pounds once it gets going. There we go. God, it's getting confusing. Just because I'm trying to do so much that there we go. All right, let's get a reading on this beast. 1400. $1,520. 1384. 1400. This is 15 volts. That's 24 volts. 1600. 1600. Oh, 20 volts. 1700. 1784. Oh, wow. There we go. The bearing popped out. That's awesome. Got to make a new one. That was at 20 volts. Didn't get the tack reading, the last tack reading. That kind of sucks. But the bearing popped out. What am I going to do about that? 1895. Oh. Wow, that's cool. So right around 1800. And we're gonna this flywheel is dope, man. This thing weighs about 5.5 pounds without the magnets. No, I'm just kidding. Weighs about 2.2 without the magnets. Weighs about 5 pounds with the magnets. And it's just whipping. Power is off, ladies and gentlemen. And that's exactly why I built that. So it could do that. So I'm just gonna run this one now because this one is vibrating, like vibrating the table. It's not shaking it, it's like vibrating it, which is a little different in my mind. 25 volts. Oh man, I smell something. You know what? I got a really good idea. I was trying to use the Litz coil, which is this one right here. But right now it doesn't appear to want to be used. It's getting a little warm. So what I'm going to do is I'm going to hook up my counter rotator. Yes, indeed. Hopefully that one will work without any trouble. We're calling this breaking it in, man. We're just breaking it in. We're getting a good feel for our situation and our surroundings. I know that sounds cheesy, but that's what we're doing. We're making sure we're not stepping on anything. We're making sure a lot of things. Right. I'm going to make the wire, the connections, the 20 gauge connectors a little shorter. That is definitely not right. And we might swap out our little trigger for the bigger trigger that was over here. Just so we can run the dual 24. And then I got a big power supply. It's a 56 volt, 60 volt, 8 amp power supply. Oh yeah, that's going to be about as close as it can be. Now I know I didn't have a heat sink on, but that's because normally they don't get hot. I hook it up right. Normally they're whipping like as soon as it gets going. All right, let's see. Now the batteries are probably a little dead. That's why I gave it an extra push. There it goes, man. It works. And the counter rotators seem to work better than anything else I do right now, except for maybe this one. There's a 24-volt counter rotator right there. Got 2 batteries in it, trigger coil, 3 bifilar wedge coils in there. But it's got 2 circuits. It's got a 20 gauge drive and a 32 gauge drive, all running off the same 24 volts. So that's going to see why the battery would drain quicker. Hey, everybody. Welcome. Yeah, you see, the counter rotators, to me, are like way easier to build than any of this other stuff. I don't know why. It's so cool. And I've been, a suggestion was for me to get a chest mount for the camera. I think that's actually a pretty good idea. And then, I can zoom in on stuff. Everything will be great. Just the magnets are a problem with my phone, I think. Pretty much with any electronic device. There's a potential there for havoc. Now, it's not going very fast because, like I said, the batteries are dead and there's other things that are holding it back too. So this is going 1,064 right now. And it'll only get slower, I'm pretty sure. But that's awesome, in my opinion. Yeah, you can't just say, well, what'd you do? Did you just? Just is a word that's going to get you smacked in the mouth. Yeah, I just did that. I want to see you do it now. Just do it now. No, just do it. Like Nike. Just. It's like you're making it sound like it's a little thing. I don't see these anywhere else. Start showing me these, and then it'll be a little thing. That's what I say. I say it's a pretty big deal. It's not like I encourage people to do it and do it better than I've done. That's what I encourage. Okay, that's what I want. Yeah, the 9 magnets are really trying the transistors. I think they're built for 2 magnets. You know what I mean? Power is off. That's why I built it, because it's freaking dope. That's why I built it. You do all the math you want, man. That took me freaking 30 seconds to stop it with my fingers. It's dope. That's all I gotta say, man. It'll keep moving 30 minutes after I turn the power off. Well, maybe not 30 minutes, but like 15 for sure. And unabetted, I don't know. I always stop it or end up stopping it. So maybe this last time, I don't know. I wasn't timing it. But I know fairly pretty much every time it'll go 10 minutes. And I made a super duper light one, like really, really light. And it had 72 magnets on it. And it pretty much rested on another disc that had 72 magnets on it. And I spin the top disc and it would go for 12, 13 minutes without a bearing. Okay, so it's just a freaking hole on this, and I have put a little graphite powder on it, and voila, man! It was a flywheel that weighed like less than half an ounce. It was freaking ridiculous, but it was awesome. In my mind, that's awesome. You make a flywheel that weighs like what a dime weighs, and it spins for 13 minutes. Hell yeah. Hell yeah, dude. People are going to be like, what the hell? And when they try and do it themselves, they're going to be like, what the hell? How did he do that? You got to put 72 little bar magnets on your wheel or it's not going to happen. You can spin it and it'll go for 8, 9 minutes, guaranteed. You know, if you make a good one. You got to have you're making virtually what it is a toroid magnet out of little tiny bar magnets on the outside of a wheel. So just line the outside up with little magnets, and voila. Then you can levitate on another disc that has the same arrangement, just the opposite side. Here, instead of trying to explain, I may have to resort to just explaining. But I have a semi put together disc. This is actually the disc. And I ended up levitating one of my pulse motors on it. But you can see that. That's 72 bar magnets on the outside of this thing, right? And then there's 72 on this side. But then I ended up putting these, bigger, more powerful magnets on there to levitate heavier stuff. But when I would whip this, it would spin ridiculous amounts of time. Yeah, and when I say ridiculous, I know exactly what that word means. So, so cool, man. I'm excited, especially about the flywheel, man. That's awesome. That's literally, quite literally, the heaviest thing I have. I think that's moving pretty freaking awesomely for the power not being on. So I want to get my Tachometer actually. See how badass it really is. Okay. Still moving at 877 RPMs, man. And I turned the power off, what, 3 minutes ago? That's awesome. I do like to, when I like score and something's working like it's supposed to work in my mind, because that's where all this stuff comes from, in my head. That's where it all comes from. I mean, let me give a shout out real quick. I got a lot of shout outs to give to people that have helped me along the way. Peter Hall Effect 2.0, 007, Mike Does. We got Nathan, Old Man Builds. We got the opposite of malevolence. I don't know how to say it. My tongue will not allow it to. I haven't said it enough for me to say it right. Benefin, Ben. I'm gonna call him Ben. And I think other people call him Ben too, because the word is just phenomenal. It's a phenomenon, man. It's hard to say. um, lots of people have been helping me out along the way, either through their own content or through helping me on live streams. It's all adding up to me at least passing the time, if nothing else. I think that as we go, I'm kind of gravitating to more towards things I can do. Me being 40 plus years of age, I'm going to gravitate towards not learning right now. It's just not what 44-year-old people do. They do not. Some people do. I'm not going to say it's for everybody, but I'm guaranteeing a lot of 44-year-olds don't just start going to college at 44. Okay, they don't want to start learning more stuff right now. They want to utilize what they learned when they were younger to make money right now. That's what the freaking goal was from the start, for you to get an education or some sort of skills that you would then utilize in your later years to earn you a living. That's how the world is stacked up. And I know that there are loopholes in this because I don't have a job. I don't, you know, that's what I'm saying, man. There are loopholes in this where you can exist without functioning like a normal person. When I say normal, I mean you have a job, you take care of your fucking self, and thusly, you know, you don't. When something goes wrong, you have an answer for that, or you have a friend that has an answer for that, or your mom or your dad has an answer for that. When you don't, that the social network is key, man. It's paramount. It's very important that you are able to work with others. I myself am not very good at working with other people. I mean, I can be, but for the most part, I take other people in small doses, very small doses. I love to share what I do. I love to, watch what I like to watch. And for those of you that catch my interest, I'm all about it, man. I will spread your name in a good way. I don't do bad way stuff. I don't diss on people. I mean, if you're a troll, I have an opinion, but I'm working on keeping that kind of stuff to myself. Uh, all right. Well, I think we're going to wrap it up for the night. I'm going to start putting stuff away. All right. So I don't know what happened. It's like as soon as I turn on the camera, everything wants to start burning out. We got some pretty good footage today, though. But that seems to be what happens. I was working with these SG circuits, a dual SG actually. I had two SGs, one hooked up to each coil. And on one rotor, it apparently only one SG. This is from K Energy Store, by the way. These work really good. Only one SG circuit is functional on one rotor at a time. So I had this one going, the light was going, and I turned this one on, and the light was not on. Okay, and then I switched it to gen mode, the light turned on. And I switched this one to gen mode, both lights were on. But when in SG mode, only one functions properly. Don't ask me why, I don't know why. Probably because that's the way it's designed to work with just one. So the dual SG is a wash in my mind. It's like not even worth doing again. But one is definitely worth doing. And I'm pretty sure that with the proper SG, the output can charge a battery. That's what I'm guessing. I haven't done it, but I'm pretty sure that one battery goes in and then the generation circuit goes to the other battery. It's going to be awesome. It's going to be so cool. We're going to move forward. Just to, try it out, I'm going to get some dirt. I mean, I've done potatoes. I've done lemons. I've actually run a pulse motor on like a string of potatoes. One that needed about 2 volts, and lemons. So potatoes and lemons. Lemons are more voltage, I think, and potatoes are more capacitors. But just using lemons and potatoes, I got a LED to light up. I got definitely readings on the multimeter. It was pretty cool. I got a video of that too. It was really fun. But get some dirt in here, like some mud with some electrolyte in it. You know, some rainwater. Frickin' A, man. Rainwater is a great conductor. Like phenomenal conductor. Has so much different types of elements in it. It's not just electrolytes. It's not just salt. It's iron. It's whatever goes up into the atmosphere falls back down. So it's a lot of things. Rainwater. And then mud, of course. You get the dirt, you mix the rainwater in with it. You add some salt just to make it stronger. Mm. And then I don't know, man, like maybe a trough of mud. One that goes from this end of the table all the way to the other end of the table. And we shove our probe in here. And we light up our light bulb over here. Voila. That would be awesome. That would be phenomenal, man. That would be great. And that would be, I guess, well on our way to the next step, I guess. Because old man says that it's not about AC or DC electricity. I'll tell you right now, there's another way to run this. The way that it is built, I'm all for it. You know, he said it's not about AC DC, it's more about the frequency of the energy coming from the earth. And I'm thinking, even with a little bit of manipulation, that mud will have a similar frequency. I'll have to look more into it. Sounds really interesting to me. But if we look at it from a visual perspective, not necessarily an audio perspective, but a visual perspective, it's all light at that point. It's no longer sound, it's light. And light vibrates on a frequency as well. So visually, it's light, and audioly, it's frequency. What frequency we call it, though? Audio frequency, visual frequency. It's all frequency. It's all run at a certain pulse or rate. Do I believe we're all inside of our heads right now in a capacity like the Matrix? I don't believe that. And if it is so, it doesn't really matter because, it's done already. And we're not going to get out. We can, try to understand it better, maybe develop a more symbiotic relationship with the people that are keeping us captive. And yeah, it doesn't matter whether they're alien or not, they are a people. Whether it's AI, whether it's an alien, whether the Matrix is real or not, I don't know. I've always been captivated by stuff like that, though. This much I do understand is that Hollywood, they always seem to have an inside tip on the latest tech, and they always make a movie about it before it actually becomes a thing. So, I'm waiting for all the, the warp drive tech and all that kind of crap to become mainstream. I really, and if it was mainstream, or like if it was out there in any capacity, Elon Musk would have it. I think I'm not pointing any fingers, But I did see a documentary saying that like 30 chests worth of material from Tesla was taken by somebody in the Trump family. And that's common knowledge. Not Donald, but I think his uncle confiscated the chests with the data that actually, I guess, is controversial data, or the data that could like destroy everything if it got into a commoner's hands. What I mean by commoner is somebody who doesn't have the education or like me. If that information got into my hands, it'd be all about my judgment call. Then all I want to do is build this stuff and see that it works, and have fun doing it. I don't want to tear rifts in time and space and all this stuff. I don't want to destroy anything. That's not what I want to do. But apparently some of this data that could easily happen and become increasingly out of control. So, whether it was done for good or bad, I bet we're going to find out pretty soon. Can't hide that. That is in a documentary about Tesla on YouTube. It's part of the documentary that Trump has those files. I don't know if Donald Trump has the files, but the Trump family confiscated those documents. At least that's what the documentary says. Whether or not they're right, I have no idea. That is way before my birth, but I'll never forget that. I will never forget that. Whew, yeah. All right, well, I've been shooting the breeze for quite a while now. Thank you all. I appreciate it. Yeah, I'm talking about Tesla's inventions that we never seen yet. And his understanding, the true understanding, not just, AC and DC, but actually getting into the earth and using, I don't know whether you're using the earth to power the Tesla coil, which I would think you would, that the earth has got to be the source. You stick the Tesla coil with a probe into the earth, and then you use that energy that's coming off the Tesla coil to power, say, an RC car or a boat. In this case, they used 2 Tesla coils, 25 kilohertz a piece, to remote control a boat well off the coast. An RC boat, but a boat nonetheless. I thought that documentary was really, really awesome. All right. Well, thanks all. I really appreciate it. And we'll do it again soon sometime. Thank you.